what I want to do today is do a little video on exactly how we want to complete this week's worksheet in egr125. The first thing I'm going to ask you to do is verify that your computer has Notepad. You do this by going to the Start, Programs, Accessories, and it should be there. Now I'm using an XP box, Windows box, but that's generally where it's at. Okay, if you open it, then you'll have a shortcut to the program right here off, the little window off the start menu, so you can get to it quicker. It gives you a shortcut. What we want to do now is we make sure that's installed, and then we want to make sure that Quite Universal Circuit Simulator is also installed. Some notes on that: when you go to install it, it should come from SourceForge. It's free software. There's no licensing or anything like that. It does run off of Octave, so it will prompt you to install Octave. Actually, it'll do it for you, and it'll install some other little executables for you in order to make it all work. We've installed it on several computers around the college and haven't had any problems. The only real problem we've had with it is sometimes if you don't simulate properly, the simulation gets lost. There is a text file inside your .cux directory that gets huge, and I'm talking in the gigabyte range, and that will tend to degrade how fast your computer runs. So if you see this, then you might want to check that folder and check the file sizes. And I can't remember the name of the file, but the one that would be in the gigabyte range are huge. You just delete it, and then when Cux needs it recreated, it will do it itself. Somehow there's something that when it's simulating but it's getting stuck or hung up, it's dumping a lot of information in this text file, so it just keeps growing. And that seems to be the problem. That's been the only real issue I've had, which is a pretty serious issue unless you realize, hey, this is what's going on, and then you fix it. If your computer's running slow, yes, you can delete a file. Sometimes it takes longer than you'd like for it to, but it is possible. Okay, so first thing we're going to do is check that. I happen to have it on this computer, so I'm going to double click on it. And here we go. We're going to open. If you've never opened Cux before, you'll have blank here. I've actually got two projects, and if it's blank, we're going to create a new one anyway. Just about any circuit you do, you'll do a new one. If you go back to that circuit, then you would just simply select it. I want to do a new one, and I'm going to call it egr125week7. Week 7 gym. Now you see there's an EGR week 7, 125 week 7. I did try and make this video, but it didn't take, so I'm trying it again. So I'm doing a new project, just like you would be doing a new project. So I've created it. So now I see that I'm under the projects window. I have all this other stuff, and I'm not going to explain everything. Not sure I could explain everything. Just what we want to use. Okay, so I've got it created. Now I want to go down here to where it says Components, and I want to click. Over here it says Untitled, and I have this window I want to drag and drop. So I want to drag and drop this resistor. Then I want to drag and drop a ground. This is outlined in the worksheet that I'm given for this class. Okay. Now I dragged and dropped those because they were in this window, lump components, and it was the first thing I opened. I need a voltage source, and I need a current probe. If I go down to the bottom of lump components, I get to my current probe, and I can pull a current probe in. Okay. I have to change windows. I have to do the pull down side lump components in order to get to sources to do the voltage probe, or the voltage source that I want. And in this circuit I want a DC voltage source, so I'm going to put a DC voltage source there. Okay. One thing about circuit simulation is you generally have to have a ground. If you don't, it won't work. So that's why there's a ground. A lot of students will build circuits on breadboards. They don't think about a firm ground. They go to simulation. They leave the ground out. It doesn't work. It doesn't reference. You get all sorts of weird errors. But that's probably what it is. Up here along the toolbar, I have a wire connection. So I can connect all my terminals together. And my ground. Now I'm going to hit escape, otherwise it wants to draw another wire. So now I've got everything drawn that I want. I want the V1U1 on the other side, so I'm going to click on it, go up here and tell it to rotate around the horizontal axis. I think it looks a little better. I want to change my resistance value and my voltage value. I can do that a couple ways. I can click on the value itself and type what I want. 1K. Now, CUX recognizes metric prefixes. They recognize the K, the capital M for mega, the lowercase m for milli, and the U for micro. One of the issues I've had with it is if I put a space between the 1 and the K, it doesn't like it. It won't simulate it. So be careful about spacing. Things to try. So I've got a 1K resistor now. Last time I did this, I did not hit enter, so it didn't take it. The other way you can change it is click on the device and then tell it the properties. It will pull up a little box with all the properties you can edit, and I want a 12-volt battery source. I can hit apply and then make other changes, or I can hit OK and it's going to apply my changes and then close the box. Okay, so I've got it 1K, 12K. Now I want to simulate my circuit. To simulate my circuit, I've got to have a simulation command on my circuit. Right here I have simulations, so if I open that window, we're going to do a DC simulation. I'm going to drag it down. It's ready to go. So here's my circuit. I've got my DC simulation. Very easy, simple circuit. Got to start somewhere. You got to start small and then work up. Now up here, I'm on the little gear and it says simulate. When I click simulate, the fact that this is an untitled circuit is going to prompt me to save it. What do I save it as? What do I save it as? Well, anything you want to save it as. So egr125 week 7 circuit. Must do that. Okay. So I'm going to save it. Saving it in this project folder. Oh, no K. Oh well, so it's we7. Alright. What it did when I did that was it went ahead and simulated the circuit. Now that the file was named, it's simulated. So if I click back on this tab, I see the circuit that I had. If I click on this tab, which is the tab it opened after the simulation, it shows me the display. Well, there's nothing to display because I've got to select something over here under diagrams for it to display. On a DC circuit, generally speaking, you're going to look at tabular because things are changing, so you can this gives you an opportunity just to look at values. When I drag and drop that over there, a little box says, okay, what do you want to look at? PR1 is our current probe. So if I double click on it, it goes over there so where it will show up. V1I is our voltage source, so it will show you the current of your voltage source. Since we're going to measure the current of our probe, we should be okay. So you can select them all. You can select, as many or as few as you want. Going to hit OK, and we see that we have 12 milliamps flowing in the circuit. Okay. Now, I want to go up here to where it says simulation, and I want to show the last net list. Electronic simulators of circuits all use a SPICE background, and in SPICE they create a net list. So what I'm doing is I'm looking at the net list. The reason I'm looking at the net list is I want to know the path. So you see the path here is C, document settings, file name that I get right here. Make it fit. There we go. One of the biggest problems that people have with computers is files get stored somewhere they can't find it. So it's an important skill all the way along to be able to find where it's sticking your files. So if I go to my C drive, document settings, Jim DeFries, .QUCS, egr125week7 project engineer, project egr125, my mislabeled circuit .sch. I need to find that file. What I want to do with this file is I want to open it. Since I can't remember the link that long, what I'm going to do is use a little shortcut here. I'm going to highlight it, do Control C, which is copy, open Notepad, do a Control V. So now I have that link somewhere that I can look at. I'm going to go back into Cux. I'm going to quit the editor. Sure, I'll save it, even though I didn't make any changes. It thinks I did. And I'm going to go in here and I'm actually going to save and tell Cux to close. Okay, so Cux is no longer open. I do have this open and I want to find it. Well, remember where it was. It was in C, under Documents and Settings. And you can see it, we can drag this at the top. Click on that. My name, .cux, and egr125 Jim _ project, which is a little bit different from the other one. And then the week 7 circuit schematic. I want that one right there. Okay. If I click open, it won't open. It's not anything. Okay. What I want to do with this one is to open Notepad. So if I click on Notepad and I do a file open, it's going to ask me if I want to save this file that I've already got. I'm going to say no, because I know how to get there now. It went to the last place I opened, so I'm going to go back up. I'm in my .QUCS directory. I'm going to double click back in the new folder. It's not showing anything in the new folder. I have to go down here and change my file type to all. If I change my file type to all, I see that I have this circuit and I can open it. Now, Cux is closed, but I'm looking at the circuit that we just made as a text file. Now, a lot of this is not going to make sense. You could probably figure it out if you put enough time and effort into into what means what. I'm sure there's documentation somewhere if you want to read through that. The purpose of this exercise is to show you that in Notepad you can make changes to programs, C programs, PLC programs, comments, all that stuff can usually be modified with a text file. And that's why I wanted to at least show you in the class what you can do with it. The copy and paste the link, that's often handy to do also, because Notepad just gives you a place to take notes, if you will. So what I'm doing now is I'm scrolling over because I'm looking for the resistance and the voltage that we programmed in. And I'm getting over here and I see that this is a resistor. It's resistor 1. It's probably between 2 nodes. I don't know what these numbers mean. It's not the net list that I'm used to. But what I want to do is I want to change its value. Remember the space bar, so I'm going to click between the 1 and the K, do a backspace, 0.5. So basically I just changed that to a half K ohm resistor. And I want to come over here and change my voltage. Notice how it puts it in quotation marks. Anything outside of quotation marks I wouldn't change. If you do, you could corrupt the file, then when you open Cux it won't run right, in which case what do? You simply delete that project, you start over at that point if you mess up your Notepad file. If I make a change and I'm not careful and then something's not right, I can say, oh wait a minute, I can just close Notepad when it prompts me to save. I can say no. I feel pretty comfortable that all my changes are okay, so I'm going to click yes or okay or file save. And what I just did with Notepad is I changed that file that Cux created. Now what I want to do is I want to go in there and open it. Now I can't open it from there, but I can go back into Cux this way. Click on my new project. There it is. Click on my schematics. There it is. Notice my voltage is now at 15. My resistance is now at 0.5K. If I hit the simulate button, and a note is if you simulate it, it won't simulate it automatically. So if you make a change, you have to go in and re-simulate it. Once you get the simulation working, though, it's not a big deal. And I'm down to 30 milliamps, or I'm up to 30 milliamps on current through that circuit. Okay, so that's something you can do with a text file. We can do some of that with a PLC. We can do some changes to documentation. This way, Notepad gives you a chance to make changes to stuff. You don't necessarily have to have the software. If you become a programmer, C++, Java, whatever, ultimately you're going to be writing in text files. You can write them on any computer and then take it to the computer where you've got the compiler and the software to make it work, to build the program, if you will, and then you're good to go. Okay, I want to make some changes because part of this is Notepad, part of it is the start of Cux, and I want to spend a couple weeks on Cux because in DCAC we're going to do a lot of circuit simulation, and the better you can drag and drop and build these circuits, the more comfortable you are, the easier it'll be. Now we're going to teach you the mathematic ways of doing it so you can do it the old way, but if you want to drag and drop and verify your results or even see what the circuit's supposed to do, then this is a very, very handy tool. Okay. So our readings changed. We made it. Now I want to add a second 0.5K resistor. So the first thing I'm going to do is I'm going to delete that wire. Come over here, and the universality of Control C, Control V. I'm going to highlight my resistor. Control C. I'm going to click off the resistor, and then I'm going to Control V. And I'm going to wait. And it's finally showed up. I'm going to click where I want it. It copied this resistor identically, same value, everything, but it did give it a different number. I'm going to escape because now anywhere I click, I'll have another resistor. I want a voltage probe across the resistor. I could go up to lump components because the probes were in the bottom, but I also have one here that says probes. Current probe, voltage probe, the only two options I have. I'm going to drag voltage probe over that second resistor. Voltage probes go in parallel with devices. Current probes go in series. If you're making a measurement circuit, you're going to connect your wires, your leads from your multimeter the same way. Now I've got the new components I want. I'm going to connect the dots, if you will, with the wires. I can do it that way. See, at some point you do this enough, you want everything to look pretty. That's about the software, is it may do straight lines. So there you go. I want to escape. Save and simulate. So I'm going to go over here and hit save. Got my project saved. Hit simulate. The longer it takes to simulate, the longer that window will be up that you briefly saw. Where's my voltage probe? Well, I've got to click in the box and tell it to add it. Probe 2 is voltage. Click OK. Showing me 0.75. If I put in the voltage of the source, double click to get it to display, click OK, it's showing up. One thing that I wanted to show you from the last time I did this was, what if they don't all show up? Look for a little red arrow, which means your box is big enough. So if I drag it out, it makes it big enough on a table. It guesses on table size, and you have to resize it appropriately. Anyway, it tells me now my current is 15 milliamps, and my voltage drop across for that probe is showing 7.5, and it's showing me that my battery is sourcing 15 milliamps. So if I come over here and I did the longhand circuit analysis, that's exactly what I'd get. Another handy thing I can do with this, easy to start with, is I can go in and do names. So I can go in and say, I want to name this wire. Think of it in terms of a test point. So let's call it TP1 for test point 1. We'll even make it capital. So I click it, there it is. I could have a test point on top of the battery. I could have a test point in my ground. I could label it ground. But I just want the one test point. The nice thing that test points do for me is, now if I go back and simulate it, and I click, my test point voltage reference to ground becomes something I can look at. So now I can look at my test point. So if you're careful with your test points, you don't necessarily need voltmeters across all your components. However, it's not a bad practice to do it, because that way you can see the individual voltage drops. Okay. So in DC-AC, we're going to analyze the circuits. We're going to do this. We're going to do a lot of circuits. We're going to do DC, we're going to do AC circuits until we get the hang of it. And you can see the readings of the most recent simulation. I labeled a node, and for question number 15, which is the last thing on the worksheet, I asked if you thought that you could go in and add a voltage probe in parallel with this resistor. So we need to go right here, and then you'd have to drag the lines. You could simulate it. Go ahead and update your simulation. Anyway, fairly simple circuit, very straightforward. I'm going to save this. I'm going to close it. If it prompts me to save, unless I know I don't want it, I usually do save selected. Then I'm going to cancel the video. Hopefully this one worked.